Welcome to Unlock Layouts. In this video lecture, we are going to discuss IC555 chip die layout. Let me start the video. Here I have a IC555 block diagram structure. We most of them know what is the need for this IC555 and where we are using this IC555, and most of the people who have done their engineering, they would have used this IC555 in their laboratory session to generate some sort of frequency. So usually this IC555 is used for oscillator purpose. It can generate a different type of frequencies range according to the adjustments of the output, adding the peripherals in the output, so we can generate different types of frequency in the IC555. See here what we need to see, it has a two comparators here. Okay, so 1 and 2, whatever we have, these twos are like a comparator unit. Other than that, we have a resistor divider, because see R1, R2, R3, we have totally 3 resistor. The value of 3 resistor is 5 kilo ohm, 5 kilo ohm accordingly. Then each and every resistor is acting as a voltage divider here, giving the input to the comparator unit. Apart from that, we have a flip-flop and as well as output driver. Then a common reset signal will be there somewhere here. Yeah, the fourth pin is the reset signal, which is directly connected to the flip-flop. Usually we can design a 555 transistor or 555 circuit by using BJT and NPN transistor. If not, we can use the same implementation by using the MOSFET. So right now what we are going to do and what we are going to discuss, we are going to discuss the complementary metal oxide semiconductor based IC555 layout design. Okay, so let me share the layout for the better understanding. So this diagram is a IC555 exact layout of ST Microelectronics fabricated IC555. So hope you can able to see here, it is LMC IC555. It is very older nanometer technology, maybe somewhere around 350 nanometer something, but even I'm not very sure what kind of foundry and what technology is this. So based on the details which I got from the Wikipedia, it is like showing 350 nanometer of the 350 nanometer design they are used for this designing of this IC555. Let me discuss one by one. So whatever here you are seeing, the larger square pad, so these are all like pads. So because in the older technology they don't have a bump pad, usually they will create a wire pad only. So wire bonding only they will use, because this IC555 is a dual in package. Okay, so dual in package is a kind of packaging technique of the IC. See, next to this pad they have a diode connected structure. See this one. So this is acting as a ESD diode. So next to the pad only, wherever the pad is there, next to the pad they have some device. Okay, it's a source and drain kind of structure you can able to see here, but this is not a source and drain structure. By using the MOSFET they have implemented a diode here. Okay, so maybe gate terminal and other one more terminal will be shorted together and it can act as a ESD diode. Okay, so other than this ESD diode usually they will connect it to the ground pad. Okay, we'll discuss where the ground pad is there, wherever the routing is going from the ground pad to another the complete routing style, everything we'll discuss later one by one. So now this is like a rough idea about the pad. So we have a pad, next to that pad we have a ESD diode. So wherever you go, any kind of pad, so this is another pad, so this another pad is also connected here. See here you can clearly see, we have already discussed in our previous layout, there are something called stretched drain devices. Okay, maybe source will be stretched or drain will be stretched. So those kind of devices are there, stretched drain device and stretched sources device. So in order to prevent the ESD event, they have used stretched drain device. See, this device is calling as a LD MOSFET. Okay, maybe they will call this device as a LD MOSFET. If not, they will call this as a ESD diode, but this is a stretched drain device, because see, the distance between the source terminal and the the drain terminal of the distance here, it is very larger distance. So it is a kind of ESD diode, okay, structure drain ESD diode. Same way we have totally we have 7 pins in the diagram, like first pin, second pin, third, fourth, fifth, sixth, seventh, eighth. Totally we have a 8 pin because it's a dual in package. See, wherever you go and see the pad, all the pads will be consist of one diode. So this diode usually they will use it for ESD, that's all, because this dip dual in package, that is called a dip, right? So this dip will be handled by human, will be handled by human. So there may be a chances of occurring ESD because there is a point of human can able to accumulate some charges and human can able to discharge some charges from his own body. So that is like human body model of ESD. So in order to prevent those ESD event, wherever the pad is there, they have internally added this ESD diode here. So other than that, we need to discuss the internal cross sectional of everything, because this diagram will give the clear idea about the routing. So let me start from the beginning here. So whatever you are seeing here in the straight line, these are all a resistor divider, because we have already discussed in our previous diagram, it has a 3 resistor R1, R2, R3. So each resistor consists of 5k value. So fine, let me show you how the resistors will be there here, and I will show you the resistor pattern matching and everything, how the design, how they have structured here. So here whatever you are seeing here, everything, the square boxes here, this is completely this one is a complete device. Okay, see this block diagram, let me highlight with some additional colors here. First I will select, then I will highlight some color. See here, this portion is a resistor, because on top of that they have a contact. So if you take a closer look, see these are like a via contact. Okay, these are all like via contact, and bottom also they have some additional via contact, because see I have I think I have routed something here, so that's why you may not able to see this. Okay, let me delete this. So here hopefully you can able to see some via structure. So here as a 5k resistor, they have divided into 2.5k resistor. So totally we have a 6 resistor here. See here, resistor number 1. So this is your resistor number 1. Let me just I draw some straight line for understanding. So this is your resistor number 1. This is your first resistor. Then come to next, this is your second resistor, and then come to here, this is your third resistor, and we'll move on here, this is your fourth resistor, and this is your fifth resistor, and this is your sixth resistor. So totally we have 1 2 3 4 5 6 resistor. So they have divided each resistors into 2.5k, so that overall they can able to implement 2.5k as a 5k. Okay, so they are adding it into serial connection, okay, series connection, in order to derive that 15k resistors. So they have implemented the resistor layout here. So see here the connection from the each resistor, because here they have implemented interdigitization based matching pattern, because see here you can see this resistor and another resistor. I'll make a different color for better understanding. So the first resistor, this resistor, okay, and then the another resistor. Okay, let me take a different color. So this one and this one, yeah, these two resistors are connected in the different color. Okay, so because see they have interdigitized this pattern, so this resistor and another resistor is connected together. On top of that, so one more resistor here, so this one and this one is connected with interdigitization structure. They have implemented interdigitization structure here, but the first resistor, they have not implemented any kind of matching pattern here. They just kept it side by side. The first resistor here, whatever it is there, it is directly connecting to the another resistor, so which can able to create a 5k of resistor. Rather than the right side block, the left side block, they have implemented interdigitization routing matching pattern here, and the connection also they have created one with another device. Okay, they have implemented some matching pattern here, interdigitization matching pattern. So this one we need to understand very clearly, because the matching pattern of the resistor most of the time you will get confused. So here they have implemented interdigitization matching pattern, and as well as the normal resistor, they have not implemented any matching pattern here. Okay, so let me delete everything. Then what we need to discuss here, see this image, based on this image, we can easily understand the connection. If you want, we can do the reverse engineering for the layout. See the resistor, if you go to the schematic diagram, we can easily understand how the connection is there. See, from these two resistor divider, this resistor divider is connected together. Let me draw a line of thing to understand it very easily. See, this one is coming and connecting to a pad. Okay, so fine. Okay, so I'll make it a light color. So this one, this connection from the resistor, this connection is coming and connecting to a pad. So if you go to the schematic, from the resistor, whatever the line is coming from the resistor and which is connecting to the pad, so based on that we can identify what type of pad is this. Let me open the schematic. So here from the resistor, one net is connected to the VCC power supply, which is pin number 8, and another from the another side it is connected to the ground. So now from the resistor we don't have any other tap, because here there is a tap to a NPN transistor, but here there is no tap in the pin number 8. So that the pin number 8 is there, whatever we are seeing there, it's a pin number 8, so it's a VCC power supply. So this one, whatever we are seeing here, from the resistor it has a 2 junction resistor. So from the resistor it is directly coming to your pin with, there is no any other tap here, so which means this is your VCC power supply. Okay, so we can able to identify this as a VCC. So if you want, I will create normal thing one, fine. So this one is a VCC, so which means the pin number 8 is, it's a pin number 8. Okay, so it's a pin number 8 and as well as it's a VCC. I'll make it little bold and I'll keep it as a size wise, I'll make it 54. Yeah, so now we can easily understood by by the layout, we can able to easily understand it's a pin number 8 VCC directly coming and connecting to a resistor. So let me trace out the another net of the resistor, because the another net of the resistor is connected to the ground signal. So whereas this junction, the resistor is started here, because this is where the junction is starting. So let me trace where this pin is going exactly. So from here to here, all the way it is coming down, everywhere all the way it is coming down, again it is going from here, there is a small bending, then again it is coming all the way to the down. Yeah, okay, all the way to the down it is coming. Yeah, from here it is going, and here, yes, exactly, it is connecting to the ground pad. Yes, this is our ground pad, because I don't want to create a large number of layout. I'll highlight this in the color of green. Yeah, see, now we have did the reverse engineering for this particular layout. So one side the net is connected to the VCC power supply, another side which is directly connecting to the ground pad. So because here our resistor is ending, so this is our another portion of the resistor. From here the routing is coming with, I have highlighted in the color of green, all the way it is coming down, it is coming down, it is coming down, and finally it is connected to this pad. This is your ground pad. See, because usually ground pad will have a larger number of metal connectivity, because ground and power always they used to give the large number of metal width. So here hopefully you can able to see how much metal width is there for the ground pad, and as well as it has consist of a EST diode also, and around the chip, the completely around the chip is connected with the ground signal. So this one where the around the chip, the inner line, the white color inner line, hopefully if you are following my mouse point you can able to identify the inner line, wherever it is going, all the things are ground, everything is a ground pad. So see, they have implemented everything as a ground connection here. Okay, so this one is the ground connection, but this pad is a ground pad. Okay, so we have another pad also here, we have another pad which is located here. So if you want, we can backtrace that. Okay, what kind of pad is there, we can do the reverse engineering for this. So apart from that, I wanted to show you few things in the source and drain connection. See, we'll go here, we'll see here it is the kind of MOSFET structure which is consist of source, drain, and as well as gate terminal. So let me highlight which is source and which is drain and which is drain terminal. So this one, this portion, first I will complete, then you can able to easily understand which is gate and which is, yeah. So this portion I will highlight in the another blue color line. See this connection is the gate connection, okay, because it is coming from the gate, so everything is the completely gate. So this one is the gate, okay. Then in between they have a small line, right? So all the things are like source and drain connection. So here all the source are connected to some other wires with a single wider connection, and drain they have taken as a tap in the top side. So this is the drain connection and another one is source connection, okay. So easily we can do the reverse engineering for this, which kind of connection is this. So we'll come to the bottom side here. See this, you can easily able to understand which is source and which is drain and which is device which is surrounded by the guard ring. See whatever you are seeing surrounded by this IC555, this is the ground guard ring because it is connected to the ground pad. Before already we have discussed which is ground pad. So this is our ground pad, okay. So from the ground pad it is connected around the device, which means it's a ground guard ring, okay. So this is the guard ring, and then internally we have a source, drain and gate connection. See this metal line, let me highlight for the better understanding. In the top side whatever you are seeing exactly, all the connections are a drain connection, because see here it is going and connecting to a different pad. Okay, so let me complete this. So this net, see this net is the drain connection. They have taken the drain connection here, whereas source already by default they have connected to the guard ring. By using the different structure they have connected, and internally see how the way they have taken the source connection here. See this is your drain connection, in between we have some metal is flowing through, right? So this is your gate connection. So whereas the gate is directly coming and connecting to some pad here, in on top of that see we have a pad. So from the pad the gate is deriving the signal. So we'll go to the schematic and see what kind of pad is this which is connected to the gate. See there are two chances, okay, because there are two chances. One may be threshold, because the threshold is the one which is directly going and connecting to the gate. If not, there is another signal which is directly connecting to the gate is CONT, okay. So there are two signal, and other than that we have a triggering signal also. See this triggering signal is also directly going and connecting to the gate, okay. So this, in this case maybe this might be a triggering signal or count signal or threshold, okay. So in order to find which is the net, the proper net, we wanted to do more research for that in the same layout, so that we can able to easily identify which kind of net is that. So then I will come to the same layout. So this is how they used to do the connection for the source, drain and everything, and this is how they used to connect from the pad. They used to take the connection to the internal circuitry. So within this layout we have a multiple blocks. One is like, as we discussed in the previous schematic, we have a driver circuit, and we have output driver, and as well as it has a two comparator, and as well as it have a resistor divider block, and there are so many additional blocks are there. Let me show you the another block diagram for you where the blocks are exactly located. Yeah, see this is the figure what we are discussing with respect to the layout. So already we have discussed the block, the yellow color, like the highlighted box. So this is our resistor divider. So they have created 2.5 resistor, and then they have implemented interdigitization based matching pattern here. So this is your voltage divider block, that is nothing but our resistor divider. And right hand side we have another block. So this block is a comparator block, okay. So this is our pure comparator block, and the middle one which is highlighted in the sky blue color, so this is your current mirror block, because internally IC555 has a current mirror. So this is your pure current mirror block. So then underneath of that we have a red color one. So this red color one is a flip-flop block, so where they have kept our flip-flop, okay. So again we have another block. Already we have discussed about some source and drain region connection, right? So this is your discharge transistor, okay. This is a single transistor, is a discharge transistor. Then we have a comparator. Our comparator is located here, okay. So from this layout we have clearly understood this is your comparator block, okay. Our comparator block is located here. So see the dotted circles whatever you are seeing, those are all like via, okay. Everything whatever square box and rounded shapes you are seeing, everything is a via. And the straight line whatever you are seeing here, so these straight lines, let me draw some line. So these straight lines are the gate connection. So this straight line, because it's a comparator, so it has a gate signal and it has a source and drain terminal. So this straight line, whatever I have highlighted, everything is the gate connection. Okay. So then in between the source, in between the gate connection, we have a source and drain region. So source and drain region, you know how they have connected. They have taken the metal tap and they have connected in the bottom here. Okay, then it is connecting to some other devices here. I don't know what kind of devices is this. It may be a diode or any other kind of structures device will be there. Okay, so because I'm not very sure about what kind of device is this. In our previous video, we have already discussed that 8266 ESP 8266 chip die layout. So there I'm not able to show the source and drain connection because the figure is not proper, the image is not very clear, whereas here the IC555 layout, the picturization of the dissection is very clear and easily we can able to understand which terminal is source and which terminal is drain, and the way how they have routed the signals from the pad to internal circuitaries. Okay, so if you want this image, I'll give the download link in the below description. If you want, you can go and download. Okay, then you do your own research in the same chip die diagram.
I hope I have given some valuable information to you in this video. Thank you for watching my video. If you like this video, please click like button and share this video to your friends. For more details about this video, please contact us to my email ID and follow us on my Facebook page and Twitter page, and kindly subscribe our channel and don't forget to click the bell button.